Very good. So hello and welcome everybody. This is Kubernetes SIG API Machinery bi-weekly meeting. Today is May 3rd of 2023. We have a packed agenda today and a bunch of interesting things to discuss. But let's begin with Daniel Lavalamp and his first topic.
Hi, everyone. If you saw the email on the API machinery list, I'm stepping down to spend time with my family, basically, and gonna take a long sabbatical, really long. So yeah, you're not gonna see too much of me for a while. And I have proposed that Joe should step up to be API Machinery TL. I think he has been doing lots of stuff and for a long time, and yeah, meets all the qualifications that we could have. So I hope you'll join me in supporting Joe. And if you've got any concerns over the leadership change process or lack thereof, drop Fede or me or David a line on Slack. But I don't think anybody can do a better job. So yeah. So congrats to Joe, and I will check in on Slack from time to time. Yeah, and I'm gonna miss everybody. Yeah, I guess that's all I've got to say on that topic.
Well, so can we react, right? I want to say thank you. I've really enjoyed working with you. I haven't followed my email close enough, but thank you. I will miss you. And hello to Joe. Yes, thank you very much for being willing to take that on.
Thanks, Mike.
Yeah, thanks so much, Daniel. We really appreciate all the years of amazing service to the SIG. So I'm super excited to help out.
We will miss you a lot, Daniel. I've been saying this, and yes, we are very grateful. These are large shoes to step in. Thank you, Joe, for stepping up and accepting the challenge. And yeah, we will miss you, Daniel. So makes me happy that you can focus on what is important for you.
Thanks. I will come off camera just for this.
Oh
yeah. So it has been great working with you. It's been like 9 years now. I know it takes a lot to keep doing this, and I really hope you enjoy your time with your family. And if you change your mind, look me up, give me a call. But wish you the best. And to Joe, thanks for your work so far across the client and the server and deep in the guts, and look forward to working with you more closely.
Very good.
Y'all are way too kind. Yeah, I'm really gonna miss everybody a lot. So I have some mixed feelings, but yeah, it's gotta happen. All right, should we go on before
yeah, we start praying. Okay. Very good.
Let me give Richa an intro here. A few weeks ago, we discussed this idea of when API servers are at mixed versions or support different resources, why not just have API servers proxy to the other API servers when they don't understand a version that another API server does? And Richa has put together a demo of that based on my extremely skeleton-y KEP. So yeah, let's hand it over to Richa.
Thanks, Daniel. I'm gonna try and share my screen.
Okay, let me know if you can't and if I have to authorize it.
Yeah.
I will stop sharing mine first.
Are you able to see mine?
Yes.
Now? Great. Okay, hi everyone. I'm Richa, software engineer at Google, and recently I've been working with Daniel and Han on implementing a prototype for the unknown version interoperability proxy. I'm going to refer to that as UVIP for the demo. It's a mouthful to say all of that. The link to the KEP is here that Daniel had initially written. It's still a skeleton, as Daniel already mentioned. So we're going to add more details in the coming days to it. Although Daniel already went through the problem statement, I'm just going to quickly give an overview about the problem statement that the KEP addresses and the proposed solution. So right now, if a cluster undergoes an upgrade or a downgrade, it can have multiple API servers at mixed versions, and not all the API servers are able to serve every resource at every version. So the proposed solution is that we will add a filter to the aggregator layer, aggregator layer's handler chain in the kube API server, which will proxy clients to the identified API server, which is in fact capable of serving that incoming request. So this is a slide that shows basically the two types of control flows that will happen. One, the blue arrows, the blue numberings is for the control flow when the request is handled locally, and the green arrows and the green numbering is for the scenario where the request is proxied to a different API server. So starting with the user making a get call to bad jobs v1 API, and seeing that the request lands in API server A here, we'll go through the handler chain for kube API server A, assuming that the first filter that it goes through is authentication. Number two is where it will perform token auth, assuming again that the cluster is configured with token auth. Once auth has been determined for the user, the request is going to go through the remainder of the handler chain to finally land in the UVIP handler, which we have implemented in this prototype. Zoomed in version of the UVIP handler is right here. So within the handler, we are maintaining a map for storage versions where the keys are the GVRs, and the values for each of the GVRs is a list of API server IDs that are capable of serving that GVR. How we are populating this SV map is using storage version informers that we are maintaining in this handler. So continuing the flow for the request, after the request comes in the UVIP handler, we are going to retrieve the list of serviceable by API servers from this SV map for the requested resource. If it is found out that the local API server ID exists in the retrieved serviceable by list, we are going to follow this blue arrow, which means just pass the request to the next handler and serve the request locally. So once ODC has determined that the request is able to be served, data is given back to the user. If in fact it was found out that the local API server ID does not exist in the retrieved serviceable by list, what we do is pick a destination API server randomly from the list and identify its network location. So currently, to identify the network location, we are looking at API server identity lease objects, where we are storing the host and the port for the API server, the identified API server in the lease objects labels. This is only tentative right now. We haven't found out a proper place to put this stuff yet, but this will change most definitely. So once the host and port information has been found out for the destination API server, we prepare to proxy the request now. We prepare a proxy transport with the TLS config using proxy client cert key pair. And this cert key pair is the same cert key pair which currently is used to determine auth between aggregator and extension API server. Within the TLS config, we are also mentioning the CA to be the server CA cert for the destination API servers. We're also recording the remote users as XAuth headers in the proxy request and passing the original request that had come to API server A. So once the proxy transport is ready, it hits API server B here, goes through its handler chain. Again, the first handler that it goes through is authentication. And how authentication is performed is first the client, which in this case is API server A, is going to try and find out that it's connecting to the right server. So when the server, API server B, presents its server certs, it's going to verify using the server CS cert that we have passed in the proxy transports TLS config that the server is the right one. After the server has been identified correctly, the server will try to ensure that the source is, or the client is coming from a legit source. To do that, it's going to look at the proxy client cert key pair, which we are passing in the proxy transport here, and will match its authority with the request header client CF file that the API server B is started with. So essentially, it's using the already existing request header auth to do MTLS between the server and the client. Once auth has been determined, then the request is going to go through again the handler chain and ultimately land in this UVIP handler. And this time, it will be found out that the request is in fact able to be served locally. So we follow the green arrow here and then pass the request to the next handler in the local API server B, auth is determined, and data is served back to API server A and finally to the user. This is the flow for the prototype that we have right now. I want to pause here and see if there's any questions.
The apologies if I just don't remember the API. The storage version does not today hold a network address accessible from one API server to the other, right?
No, it doesn't. We weren't able to find that information from there.
Okay. So
Yeah, I think Richa has a slide coming up with the open problem still.
okay.
But she talked about it under 6B, which is using that lease.
So yeah,
okay.
the server, the storage version API has an ID, so you know which API server, but it doesn't tell you where on the network that API server by that ID lives. So that's an open problem.
And there are two other pieces of information you need. You also need to know the server name, like if it's not going to get signed for an IP, right? A lot of places don't sign for IP addresses. And you will likely also need a CA bundle to verify the server you're connecting to. Is that also covered?
Yeah, so
sorry, I don't want to get ahead. That part of the connection, I look at that and I say, someone who can control that can control a lot.
Yeah, there's already the very powerful CA that the aggregator's client cert is signed by. So the proposal is to reuse just since all the API servers are already configured with that CA, and aggregator is already using that CA to dial out to any aggregated API servers.
Yeah, but that one's only a client cert, it's not a serving cert.
Do we need a serving cert?
To identify the
you're worried that you're worried that something else may have a client cert for that. So if we use it as a
are we getting ahead? Are we talking about?
We're way ahead.
Okay, sorry.
Why don't you keep going, Richa?
Well, there's two other hands. Yeah.
Oh, okay, yeah. Mo.
Antonio had his hand up first.
Oh, okay. Antonio?
Yeah, is that we already have the IPs of the API server on the list.
Yeah, this path already exists, but it doesn't end up at a other API server, like in Kube API server, it ends up at an aggregated API server.
Well, okay. I mean, the information is in each CD on the list. So if you want to get it, you have the IPs there.
Which information?
So, well, the API server it create these lists to generate endpoints for the Kubernetes.default service. So, and in these lists, you have the IP of each API server.
Yeah, but that's not guaranteed to be reachable.
Yeah,
like that must be reachable. That's by.
So we do currently serve or store API server IPs in an endpoints object. We're getting ahead of ourselves here, but the difficulty with that is that those IP addresses are reachable. Well, they might be reachable from the there might be multiple network zones, so they might be reachable by the nodes, or they might be reachable by only API servers, or they might be reachable by both, or neither if they're configured wrong. So that's a issue.
No, that's for conformance. Those APs must be reachable for any pod in the cluster. I can tell you, I added this conformance test.
Okay. So one thing that might go in there is the advertise address, which may end up being a load balancer and not API server's address.
Okay, then
And we need to go directly to an API server. So if it's configured like that, that wouldn't be sufficient.
Then you're right. Yeah, that's the advertise address, not the real address.
Right,
okay.
Right. Mo? If we answered that question sufficiently.
I think I'm still like a little bit confused about like how the networking of all this will work. Maybe that can come later. I was just gonna ask, I assume somewhere in this whole thing there's a short circuit that says you can't just keep proxying forever. So like if one server
So if it is found out, like I said here in 6p.6, if the storage version APIs tell you that the service, the resource is able to be served locally, there is this check that we are doing. So it will end the proxy.
I mean, but much more specific, which is like if you're confused and you think a different API server can serve it and it can't, and then it turns around and it tries to serve it back at you because it thinks
that's a good point. We should probably add a safety, like if it changes between the proxy and we should add a safety check. Like if the auth in mechanism was the client cert, then just serve it locally, no matter what. And as part of this, if we try to serve it locally and we don't actually have it locally, we plan to serve 503s and let the client retry.
Sure.
Yeah, I think in steady state, it should be very, very rare that something serves or like something status changes between the originating API server attempting to proxy and the receiving API server actually attempting to serve it. I think that should be pretty rare, but it is easy to make sure we don't do the wrong thing. So we might as well
have a check. Yes.
Cool. Let's keep going.
Okay, so for the demo, I have an integration test for which in which I have created two API servers. One API server was created with all the APIs enabled, and the other one was created anyone. For an example, the batch API disabled. So I try to create a resource using the first API server, a resource for using the batch API for API server A, and I try to retrieve that same source using resource using API server B. So for the demo, I have this test. And like I said, I'm creating two servers here. In server B, I'm disabling the batch v1 API. I'm creating client sets for both the servers. Then I'm creating a resource job using client set A, and I will try to retrieve that using client set B. I'm just going to run it here. And then I'm logging this line, which will say that server B was able to retrieve the jobs of list length 1, where the job retrieved was the test job, which in fact was created by server A right here. That was the small demo that I had for the integration test.
That's awesome. We should have more demos that are running integration tests.
For the to-do still, like we already discussed, there is we yet have to find a place where we want to store the API server's network location. For the storage versions that we are using right now, they inform you about the versions that are currently being can be read by the API servers from HCD, and they don't tell you if those versions are being able to be served by these API servers. So we may want to enhance the storage versions API to also store this served by information. So that is also going to come next. And then right now we are routing all types of requests. If it is found out that the resource is unknown locally, to the destination API server, including discovery requests. But eventually in beta, we want to have a merged discovery doc that is going to be served, which is like a common doc that should be served by all the API servers. That's
Yeah,
pending.
I think we should only be proxying resource requests, and discovery shouldn't
Only
be.
resource requests.
Yeah, discovery shouldn't be a resource request. So, but yeah, until we merge like we want to switch discovery so that it merges the information that we already have in etcd, so that we can present clients a complete list of what is in the cluster and available to be talked to. Because either, like, if you've got a different configuration, like sending either the old or the new discovery document is going to be problematic for clients.
Yeah, although in the process of building that, something like a watchable resource becomes pretty reasonable to attempt it with.
I mean, it's true. You could be watching the storage version API, honestly.
Right. So
that would get you only built-ins, though, I think.
Okay. Well, but something peer that covered all types, maybe.
Yeah.
Joe has a hint.
Oh, I was curious. It looks like I might know the answer, but I'm curious if you could tell me for sure. Would this mechanism work if you were, say, like turning on a currently disabled API by switching the feature flags on one of the API servers? Because it would announce, it seems like it should, but I was just curious if you knew for sure.
I'm not sure if I understood. Did you say that?
Yeah, I missed one word in there.
If you switch, say, the feature flags on the API server to enable, I know there's going to be maybe a cut makes this easier, but if you were to flip the feature flags on one of the API servers to enable previously disabled API, maybe it was an alpha API or something, this would then immediately start routing all requests to that one, right? Because it would register and start recording that as service.
Yeah, that's the idea. Yeah, that's the desired behavior. And one of the reasons why it would be good to merge the discovery document. Also, right. Austin is asking a question in chat. Could we use this to horizontally scale API servers and shard GVRs across different etcd clusters? No, I don't think you would want to do this, because these proxied requests use up egress bandwidth for both API servers. So they're twice as bandwidth heavy as a regular request. We think this is okay for a small amount of requests while API servers are in a mixed version state or mixed configuration state, but I don't think you would want to run this way forever. If you like, I guess if you wanted to use this to shard or spread API servers, you would probably have to do something crazy, like have a 2-layer system where you've got a set of API servers that is just doing the routing and another set of API servers that does the serving. And I don't think that that's a goal. And maybe it'll be possible to configure things that way, but I'm not sure I want to give people instructions.
There might be another one. So for CRDs, say one of your like API servers, its etcd got partitioned and it wasn't aware of some new CRD, it wouldn't then announce that CRD is served. So you would probably route away from it to the API servers that do have that CRD registered. Right?
Yeah, this because all API servers are equally capable of serving any custom resource, this is really only effective for built-ins. Yeah. All right. Any other questions? Yeah, I think we can have the merging discovery discussion later.
I was going to ask
let's debate about that. Sorry.
So, like, what's the expected behavior for aggregated API servers? Do they just keep doing their thing?
No change for aggregated API servers. Yeah, no change. And I think David is right that we need to double check that we can actually do what we're doing with the client cert.
Yeah, and the serving cert. So on the aggregated API servers, we have that information of this is the server name, and then this is the CA to verify it.
Yeah.
So I think that needs to get fleshed out. I think it's definitely solvable.
Yeah. Yeah, and like, are we going to sign with a host name or sign with an IP?
Yep.
Yeah. But for the demo, Richa hooked up the existing
Yes.
client cert to the existing request header auth, like client CA.
Yeah, it's a great starting point.
Yeah.
All I'm saying is that for the enhancement, that needs to get spelled out, and
Right.
And use this thing from a lease isn't super compelling. Just it feels like an abuse of what we're building versus some sort of structured field, and because I think you need a CA.
Oh yeah. We can't get this out of the lease. That's
I
not.
don't think
That's
there's
not
any
what leases are
practical way
for.
for you to get it there. So
Yeah. We got to have a real solution for that. But yeah, I think the demo was super cool, and thanks to Richa for putting that together. And yeah, it's great.
Thank you. It was a great learning
got a hand
opportunity
from
for me.
Oh.
Sorry.
So
Last
Mo,
question.
you have a hand. Is it stale or is it a new one?
Yeah, I was going to ask. So, I mean, this is relatively complex sounding overall. As a person working at a cloud provider, the networking makes me nervous because this changes the networking requirements in a way that didn't exist before.
Yeah. So our answer for the network effect is if you don't have connectivity between your API servers and you don't want to add it, that's fine. Instead of proxying, we're going to serve 503s, which is an improvement on today's state. So today's state and the actual problem we're trying to solve is right now you might get a 503, you might get a 404, and it's pretty bad to serve people 404s for things that actually do exist. So
yeah. Upgrades are the primary time where this happens, right? This isn't meant to be like part of your steady state.
that's correct. Yeah.
It is.
Yeah, but like depending on like how you're set up and stuff, you could be in a split version configuration for like 20 minutes to an hour or a couple hours, depending on how fast you are about doing the rolling restart. So it's not an insignificant amount of time.
I do have a question. So the KEP is still work in progress, and there is no version tag yet, no milestone. So what are the next steps here? Is this like alpha on the next one?
Well, I think now that she's got this great demo, Richa should take over the KEP, and I think filling out the other sections, like we have a proof of concept. So filling out the other sections seems like the next step.
Okay. Yeah, just wanted to make sure.
And for my part, I'm going to be paying special attention to the how do I find it? How do I confirm it is who I think it is?
And storage version is still alpha also, right? The API. So
Yeah. Storage
that does
version
not prevent us from going alpha though, right? You can have an alpha feature dependent on another alpha feature.
Yeah, no. I was saying that maybe as you do this, you'll get the other one to beta too while you're at it.
Right.
Only way to promote the feature.
Yeah. And we need to add Jordan pointed this out, but we need to add a bit to the storage version API indicating whether it's actually served, because you could understand storage versions that you're not actually serving, and then it would not be good to proxy things over then we'd have Mo's problem for real, where we're proxying to servers that can't understand them or can't serve them. So we've got to adjust the storage version API.
Yes, and if that's adjustable, that can maybe help with some of the other problems as well. The networking one in particular I'm thinking of.
I don't, because the storage version API is gonna list like the ID all over the place. So I don't think that's a great place to put the network identity or a
Okay, fair enough.
We're trusting.
Okay.
So yeah, yeah, we thought about that one. Okay, we're halfway through. I want to make sure we have time for Sean's demo.
Thank you for listening to me.
Yeah, thank you very much, Richa. This is great. I'm thoroughly in favor of showing demos as tests that pass. Sean, do you want to take it?
Sure. Can I present a few slides?
Yes, I was going to ask you if you wanted me to present or you can do it.
Okay, let's see if I can. So are these slides visible?
Yes.
Okay, great. So there's been a long time issue of moving from SPDY to WebSockets as the bidirectional streaming protocol. SPDY's been deprecated for, I think, about 8 years. And we think we've made some progress, and I'd like to give some context and a little background on what we propose, and try to get some feedback to see if this is the direction that seems productive, and maybe some other specific questions on whether or not there should be a KEP. I'm going to skip that. So just as some background, I've tried to create a diagram to show how we use bidirectional streaming, SPDY, for some kubectl commands like exec, attach, copy, and port forward. And as it is now, the API
hey, Sean,
server, yep.
We're seeing a blank slide. Are you? Oh, there it is. There it is. Okay, thanks.
Oh, sorry. Is it visible now?
Yes.
Yes.
Yeah, now it's visible.
And by SPDY, do you mean HTTP 2?
No, I mean SPDY 3.1.
Thank you.
So the current bidirectional streaming protocol that Kubernetes uses, at least for these kube control commands, is SPDY 3.1. And we're proposing moving it to the better supported WebSockets. I'll show some more in a second, but this is how the system and the several different components are working now, where the API server and the kubelet are basically just proxies and to the communication between the client and the container runtime. And there's actually two steps for the container runtime. There's one that calls the container runtime interface a get exec, which spins up the server on the container runtime, and then the kubelet then proxies to the container runtime. And what's being proxied is actually dependent upon the command. And so for the commands kubectl exec, copy, and attach, there is a Kubernetes specific subprotocol called remote command, which is multiplexing the standard in, standard out, standard error, and the terminal sizes and resizes across this one SPDY connection. And I tried to illustrate on the right that was the container runtime. At the other end of it,
we're seeing a blank. We're seeing a blank. Thank you.
Okay. How about now?
Now we see a picture with a right on it and a left.
Yeah. Looks good now.
Okay. So it's actually the container runtime that is consuming this data off of the SPDY termination, and then actually throwing it into this standard in, standard out, standard error for that particular container. So how do you actually get this bidirectional streaming connection? So it ends up being an HTTP 1.1 request upgrade. So is this visible too, or are we getting the black screen?
We can see it. Okay,
great. So for Kubernetes, I've actually tried to shade some of the important parts. So the exec is the sub protocol for a particular post on an Nginx pod. And then some of the query params are the command that's being executed, as well as some of its arguments. And two of the important headers are you're asking for an upgrade in this request, and you're asking for the upgrade to SPDY 3.1. And then some of the kind of reddish pink headers are the different versions that are supported for the remote command protocol. And so the response is, if it's successful, it is, as you can see in the light blue, it's 101 switching protocols, and you say what you're upgrading to and which one of the versions was accepted. And now you have the connection available to send variable length data across this connection. So why is it that we care about transitioning from SPDY to WebSockets? And if you look at the first link here, it says SPDY is deprecated. We're going to switch to HTTP 2.0. That was back in April of 2015. And the current issue is from March of 2020. So why do we even care about this? Well, we care about this if we own the client and the server. Why do we care? We care because of proxies and gateways and L7 load balancers, which are in between the client and the server, which basically just don't support SPDY anymore. Since it's been deprecated for 8 years, and WebSockets is the better supported protocol, even though it's relatively old. And a good question is, why not use HTTP 2? Well, it turns out that even though HTTP 2.0 is derived from SPDY, it doesn't surface a lot of the functionality for this bidirectional streaming. And if you look at the Golang standard library for HTTP 2, it actually throws an error if you try to do an upgrade. So it doesn't appear that HTTP 2 is a valid possibility, and WebSockets is basically the only supported bidirectional streaming protocol we can use.
Yeah, is it correct that WebSockets runs on top of an HTTP? Like it's agnostic as to what variant of HTTP you're running. So it's basically it's a like what application level protocol rather than a network level protocol. Is that correct?
It is agnostic to HTTP 1.1 or 2.0, although, as I mentioned, you won't be able to actually get a bidirectional. If you have a HTTP 2.0 request, it'll give you a 400. It won't allow you to upgrade. At least for the Go standard library, it won't.
Okay.
So one thing here is WebSockets take over the connection. I mean, you need to hijack the whole connection.
Yeah, sorry.
It's not that you can use WebSocket over a stream in HTTP2. There is an RFC and an open issue in Golang, but it's not implemented.
So in the API server right now is what's called the upgrade aware proxy. It actually runs in the kubelet as well. And that's where the hijacking happens. That's where it looks at these headers. It sends it upstream. If it gets the 101 switching protocol success, then it will hijack that. It'll spin off a couple of Go routines and just do IO copies. And so as a side note, that code, that upgrade aware proxy code in the API server is actually not needed anymore, because since Go 1.12, the standard library, the reverse proxy in the Go standard library actually supports it. But we had created this upgrade aware proxy. And as a segue here, our proposal and what we built in the proof of concept is a stream translator proxy, which terminates WebSockets in a proxy, and then for all of these channels or streams, it's going to throw them onto the SPDY client, which is going to be the same throughout the rest of the system. So what this proposal would give us is WebSockets between the client and the API server, and the exact same functionality within the rest of the components of the cluster, continuing to use SPDY throughout the rest of the cluster.
If we wanted to rewrite pieces of the rest of the cluster, would you suggest using, how would you suggest we do it? It probably wouldn't be a proxy, I'm guessing. You would have the kubelet understand the web proxy or WebSockets natively.
So the termination is in the container runtime, and there are numerous container runtimes, which is one of the biggest reasons we want to do this proxy in the API server, so we don't have to deal with multiple different container runtimes. I think Antonio has some horror stories about how long things take to get done.
Yeah, I might have misread the picture previously. Could you go back to the one? I thought it had API server to kubelet to CRI. Yeah.
Correct.
So that connection, API server to kubelet, why would we choose to have that one still speak?
So I was actually so first, the answer I think is over upgrades. Like you've got a big coordination problem if like you change that API server to Node. Like you have to keep the old way
Only for three releases.
But it's got to be 3 releases. So
yeah, but 3 releases is not forever.
It's not forever, but it definitely makes it more like it definitely makes the code more complicated. I'm not saying we shouldn't ever do it, but actually I have a more fundamental confusion about this diagram. My understanding may be off, but I actually thought that kubelet sent API server a redirect, and then API server directly called into container runtime, into the containerd. But it's possible I'm misremembering some sort of prior state or something that existed only in the design. So is kubelet actually proxying, or does it redirect?
It is. And not only is it proxying, it's using the exact same code to proxy that the API server. It's vendoring in the upgrade aware proxy.
Okay.
Daniel, think that this changes with the Docker sim and the CRI.
Sorry, go ahead. What was that, Antonio?
That before with Docker sim, there were 2 paths. One is the CRI path, and the other is the Docker sim. And with Docker sim, it already forwarded directly to the node. So maybe you are mixing that. I don't know.
Okay.
Okay.
So there's a Docker sim path as well as a CRI. Okay.
Okay, can I get back to you, Daniel, on that? It sounds like I might have misspoke.
No, I think Antonio is saying I'm confused, not you.
Oh, okay.
Yeah, that's all. Your picture here also mirrors my understanding of it.
Yeah.
And so I guess
I'm probably misremembering some old design document that I saw.
I can appreciate us not wanting to create a design here that says we need container runtimes to change. I think we probably should if we're like one of the last holdouts still using SPDY. But the one connection that we do own entirely from the API server to the kubelet, I don't understand why that one would stay SPDY. Is there a technical reason, or is it you just expediency?
So I guess expediency in the sense that trying to reduce the focus so that it's something that we own and that we can make tangible progress on, that we could eventually get, say, WebSockets throughout the rest of the system, but that, you know, we fixed 99.9% of the problem that we want to solve by just having WebSockets between the client and the API server. And actually, you know, fixing the rest of the system, I'm sure we could get to that, but if we reduce the focus, I think that we have a better chance of getting something completed sooner.
So it seems like, so if you say it's using the same code, that means like after we put this in, like 3 releases later, we could just make API server start sending WebSocket out and keep that code in kubelet, right?
Correct.
Yeah, so we move the proxy one layer down.
That would make me happier.
Yeah.
Yeah,
that
would help quite a bit.
that seems simpler than like having API server decide whether to proxy or not based on like deducing something about the kubelet.
As long as it's built such that we actually could turn the kube-api server into a pass-through instead of having one proxy to convert to SPDY and then having a different termination method in the kubelet. That would be fixed.
The failure mode I was wanting to avoid was I don't want to like wait 3 versions for this to propagate to all kubelets before turning it on an API server. It's like that doesn't seem good.
Yeah, I have no desire to do that. I just want to have an end state that doesn't keep an API server to kubelet connection using something that has been discouraged for 8 years or a decade by then.
And SPDY is like, there's been a lot of security vulnerabilities and it's not maintained, and so getting rid of it is like completely, we should probably give some sort of deadline to container runtime, like make it several years. But if we supply the code, like hopefully eventually we can flip over and make it WebSocket all the way through.
Okay.
I think the proxying is good in the short term.
So structure-wise, Sean, is that I haven't read through the code yet, but is it achievable to say that a year from now we would switch to have the API server? I guess it would be 3 releases of unconditional on in the kubelet. We would switch the API server to do a WebSocket connection from the API server to the kubelet in this picture.
Let's talk that through real quick. So if in 128 we're able to get this alpha, then 129 would be beta. So that actually would be visible now between the client and the API server. That sounds reasonable to me, that 3 releases that we'd be able to move that down.
Okay.
So, yeah, the plan is to get this in for 128 as alpha.
Okay. Who has appetite to review yet another proxy?
So I have a meeting tomorrow with Jordan, and he doesn't know this yet, but I was going to try to sell him on being a reviewer.
Okay.
I mean, I'm hoping that the translation here is like a few io.copies hooking up SPDY channels to WebSocket channels.
There's desire. I'm thinking about it like I think I would naturally be the one requested for the UVIP from, I'm sorry, I forgot how to pronounce your name. Is it Richa?
Richa.
Yes.
From Richa. I don't know that I could volunteer to do both in one release. But yeah, I'd be happy with Jordan or finding someone else.
Yeah.
And Mo volunteered to remove our upgrade aware proxy from the aggregator. So, while Jordan's reviewing.
I was trying to volunteer you, David, but I guess it serves me right. That's fine. I've been wanting to delete that code for so long.
So one question I had for the SIG was, do we think we need a KEP?
Yes.
Or not? Okay.
Yes, we're looking at changing an underlying piece that's also used by the kubelet, and then ultimately the end-to-end flow of what we're doing impacts the kube control as well, right? Because in order for it to be useful, you need kubectl to first attempt a WebSocket connection, probably, then fall back to SPDY.
Yeah,
So-
that's actually going to be the challenging part, is figuring out how to do that fallback. I don't think a negotiation is going to be possible in one request response. I think it would have to be the WebSocket executor asking for a WebSocket upgrade and then failing and then using SPDY.
that is an expensive enough call and rare enough that seems justifiable. But when you start looking at I have absolute minimum 2, I'm impacting at least 3 SIGs. Yeah, I'm thinking KEP is very appropriate here.
Okay, great. I'll get to work on that. Is there code visible on the screen now?
No, I've still got a picture of a slide and I see a
Okay.
browser.
Okay, I can show some of the stream translator code right now. It's actually there's not too much of it for our proof of concept. But if you want to look at it, then on the notes, if you look in the SIG API Machinery notes, there is a document where I've attempted to centralize and organize all of the context for this issue that's been going on for 8 years. And that also includes a link to the proof of concept PR, which is working right now. So this stream translator is working, all the integration tests work. Manually, it works for all of the cases that I've tried. And there are some E2E tests that are failing, but the integration tests are working currently for this particular code, this stream translator. Okay, that's about all I had.
Thanks, Sean.
Yeah.
Yeah.
Thanks for the questions.
Yeah, this is
Does anybody else have any questions?
I was just going to say it's great to see some progress on this after like 8 years. It's amazing.
Yep, and maybe you can update us next meeting how the meeting with Jordan went.
Yep.
Thank you. Okay, so we have just a few minutes. Mike, are you there? I'm not sure how long is this topic.
Well, we can maybe start the discussion. There might not be much to discuss. This also is a blast from the past. I believe there have been discussions on and off over the years about the desirability of building a higher plane repo. It would be indeed, as Stefan noted, one of our staging repos. It would be intermediate between API server and kube-apiserver. So the point would be to help projects that want to build custom API servers for whatever reason, and there are a number of them. And so the interesting thing is that they want functionality that's in kube-apiserver that's not in API server, right? So the aggregation layer that was talked about earlier would be, I think, my primary candidate. And so the vision is to build a higher level library with the eventual goal of rebasing the kube-apiserver to work on it and supporting other projects that want their own API servers. And the people working on KCP, I'm told, did discuss this with this group some months ago and got an agreement in principle. And they were inarticulately able to tell me that David had some concerns about how that is done or what is done. I don't understand. They just said I should talk to David about it. So I thought we should maybe just revisit it here and see what people think now.
Sure. So I am in favor of the idea. I have I have some requirements about how it would need to be built, right? I don't want to go through an intermediate phase where something is broken. And I don't want to go through a stage of let's merge a giant switch So bring in some new dependency and swap onto it. I don't want to do that either. And I want to have some sense of what is going in. So, what we would learn from the past. This has come up in the future. I think with those statements, and like someone's solemn promise that once they start, they will finish. Because ending up with half the code moved would be a really disappointing outcome.
Yeah, I think David called out the failure modes that I'm worried about too. I think the way you have to do something about like this is like it goes in staging, and from day one, it's linked in from day one, and you move code a bit at a time from one place to the other, and like everything stays working and all the tests keep passing. Like I don't think other like the like
okay, so
build
what
it separately in a giant PR like
okay, so what I
rebases.
inarticulately maybe understood was exactly the opposite of what you're saying. So rather than develop a new library and someday switch kube-apiserver onto it, it is a continuing refactoring. So we might start with a new library that adds nothing to the API server repo, and then gradually over time shift more functionality up to the intended limit from kube-apiserver into this new repo, intermediate repo.
And that would mirror how we had previously handled the staging refactors that we did. They were done, a few hundred lines at a time, and eventually built up to everything that we have today. And all the splits, all the snips that happened, so that you eliminated dependencies, happened before anything moved into staging, so that staging never had wider breadth than what was intended. And so my concerns aren't fundamental in nature. They are mechanical in terms of delivery.
Yes, procedural. Right. Yeah. No, this makes sense to me, actually. It makes more sense than what I thought I heard people telling me. So I'm glad to hear it. This makes perfect sense to me. Really, it's an incremental refactoring. You start with factoring into everything and nothing, and you shift stuff slowly from the everything into the formerly nothing.
And so you're mentally prepared for this, though. Like this sort of change is what actually led to the establishment of the KEP process. So even though you're not adding a feature and in any of like your first year's worth of steps, you still need to describe what you're doing, and we need to agree on how much moves.
Yeah,
I agree.
Of what goes in, like it's critical to agree up front.
Mm-hmm. Okay, so we're out of time. Great, thank you.
Thank you.
Very good. And that concludes our meeting for today. Thank you for coming, all of you, for the great demos, and we'll see you next time.